Hello, I am Jae-Hong Lee from Seoul National University, and I will be talking about our research development of a physical computing instructional design model for pre-service special education teachers, conducted with myself, Ju-Young Park, Yujin Bae, and Dr. Charil Lim. This is the table of contents for this presentation, and to start off with the introduction. In terms of the need for research, with the fourth industrial revolution arose the need for education to enhance computational thinking. For example, software education has been adopted as a required general subject matter in various curricula around the world. However, the teaching and learning materials for learners with special needs are insufficient or inaccessible. This is the case with certain technologies in Korea. Special education teachers can help with this if they become specialized or trained in software education, as they can select appropriate software education content according to the needs and levels of their learners. Now, keep in mind that there is a positive correlation between pre-service educators' pedagogical preparation in content matter and their performance in the classroom. Moreover, teachers with advanced preparation in teaching methodologies and strategies are said to have a greater chance of longevity in the classroom. However, for the creation of an effective teacher, thorough preparation in pre-service teacher training programs is required. Pre-service special education teachers have difficulties with instructional design activities. An example of such a problem would be difficulty in individualizing instructional support. Such problems arise as many pre-service education teachers did not fully practice the instructional design process despite its importance. Also, as each special needs learner possesses a very unique and more thorough learning need and characteristic, more expertise in instructional design is needed. Instructional models can help with this as it can serve as a tool that can visualize, direct, and manage the processes. With all that said, this research seeks to develop a physical computing instructional design model to efficiently guide pre-service special education teachers in the subject of physical computing education. Our research questions are: what are the steps for a physical computing education instructional design model for pre-service special education teachers? And what are the experts' responses to the developed instructional design model? For our research, we took into account a course entitled Information and Telecommunication, the only software education course in the Korean special education high school curriculum. It focuses on the core concepts of experiencing the problem-solving process and problem-solving in software with the following achievement standards. There is also software education training programs for special education teachers. This is part of an outline of the program done by Korea's National Institute of Special Education last year. The physical computing components of this program consist of software education with Microbit and with Albert. Regarding this, it is important to note that there is research that suggests that it is difficult to implement software education in the field due to problems of teacher inadequacy and insufficient curriculum. Going on to the instructional design models themselves, more specifically models in special education, there were models designed with the universal design for learning, as well as models that focused on specific disabilities. For physical computing educational models, we looked into models that focused on maker education. There were other models that focused on computational thinking and the utilization of the 5 E's. So from this literature review, we gathered its implications. First is that there is a lack of research related to software education and special education, and that training for special education teachers is crucial for such an education to occur. From the models, we found that models should have specific steps and examples that teachers can follow, as well as an emphasis on the importance of well-structured lessons that takes into account the characteristics of learners with disabilities. In lieu of physical computing education, there is a need to consider the computational thinking capability, and that the most common are design, implementation, improvement, and evaluation. Finally, there should be a focus on real-life events. Going on to the research methodology, we utilized Rich and Klein's Type 2 design and development methodology. The steps that we took were literature review, initial model design, expert consultation, model revision, and expert validation. Moving on to the results of our research, as stated, we developed the initial model through a literature review. Afterwards, we conducted expert consultation from 2 professionals in the field of special education. Major opinions regarding the initial model are summarized here. With the feedback, we revised the initial model. As a result, as you can see, we developed a revised physical computing instructional design model for pre-service special education teachers. This model consists of 3 main steps and 14 sub-steps. We won't go into detail due to the time limit, but we'll share some of our key insights on what we were able to receive through our research. And the first step is learner analysis, and here is the step 1.1, identify learner characteristics. In this step, pre-service special education teachers identify learner characteristics using a class learning profile template. The chart below is such an example. It can be used to help the pre-service special education teachers plan for instruction. It can also give opportunities for offering alternative methods, materials, and assessments. The next step is identify learner level, and then ensure accessibility. This is the second major step of the revised model, instruction design and development. In this step, pre-service special education teachers design and develop a lesson plan for physical computing education. First, pre-service teachers make a plan to emphasize with real-life problems. Then, they plan to make learners become acquainted with the materials and tools. Following this, they make a plan to let special needs learners understand possible solutions, provide pre-assembled physical computing tools, then decorate product. Afterwards, the seventh step is to have special needs learners share their thoughts about the problem-solving process and products. And then finally, they plan to make the learners reflect on activities. The third step of the revised model is introspective reflection. In this step, pre-service special education teachers review the lesson plan that they have developed and practice or demonstrate the lesson plan. Lastly, pre-service teachers modify or improve the lesson plan using the feedback and epiphanies gained during the practice. They use a reflective tool such as a mind map or a SWOT analysis to organize the received feedback. And they revise the lesson plan based on the feedback regarding the areas of improvement. With the revised model, we subjected them to an expert validation process. We held surveys to receive feedback on the revised model. As you can see, the panel for the expert validation consisted of 5 professionals from a variety of fields. They were asked to evaluate the validity of the physical computing instructional design model by providing ratings on the specific components of the model, then the model in general, their strengths, their weaknesses, and areas of improvement. This is the result of the expert validation on the specific components of the model. The CVI was higher than 0.80 for all items, which means the components of this model is valid. And the IRA was a bit lower than 0.80, indicating that experts' opinion is overall not in agreement, and therefore each component of the model should be revised. For the model in general, CVI and IRA was higher than 0.8 for all items, indicating that the validity of the model is acceptable, and experts' responses were mostly in agreement about the validity of the model. This table summarizes the feedback we obtained from experts. They felt that we need to consider types of students' disabilities with additional suggestions for various types of special needs and strategies for unexpected circumstances. In addition, they believed we need to reconstruct and clarify the steps for the model to accurately reflect the corresponding activities. Also, several activities should be added, including program modification and debugging, and so forth. Furthermore, the model should be differentiated from previously developed models, and the analysis steps should be subdivided. Also, the step 2 and 3 procedure of the model should be simplified. Additionally, modification of the terms and expressions of the model is needed to clarify the audience of the model. Before concluding, these are the implications for the utilization of our research. There needs to be a clear designation of roles of pre-service education teachers, and the various types of disabilities need to be considered. Also, this model serves as a guideline for pre-service and newbie teachers. However, for the talents to go beyond to the next level, creativity, reactivity, and persistence is needed. For future research, the model should be validated internally and externally. In addition, for the next step, we hope to apply this model for pre-service special education teachers within the context of distance learning. This is it for our presentation. Thank you for listening and for your interest.